Okay, now we're going to talk about synthetic division. Honestly, it's my favorite method. It's more preferred. I think it's easier. But the only time that we can use synthetic division is if our divisor is in the form of x minus k. Okay, so for example, if I were dividing by something that was squared or cubic, I wouldn't be able to do this. It has to be x to the first power, add or subtracted by some number. Okay. So for example here, this works. I can use synthetic division. I could also use long division like we were just doing, but it'll be so much faster for us if we use synthetic. So, um, so the first thing that we do is we want to divide by whatever k is. So if I set x minus 2 equal to 0, x would be 2. So that's really our k value. So a lot of times students just think of it as just dividing by the opposite of this number. That's perfectly fine. Then we're going to write the leading coefficients for each term. So I have a 1. Oops, that was a weird looking one. Let's do that over. I have a 1. Come on, pen. I have a 1. Now notice I don't have a cube term. So I'm going to have a 0 as a placeholder. -3. There's no x term, so I'm going to have a placeholder of a 0 and 1. Okay. So when we do synthetic division, our first step is we're going to bring down this number. Okay, I always draw the arrow in just to kind of help us. Then we're going to multiply. So 2 times 1 would give me 2. And unlike long division, when we're subtracting downward, this time we're always adding downward. So now I have 0 plus 2, which gives me 2. And I'm going to multiply again. So multiply diagonally, add vertically. So 2 times 2 would give me 4. I'm going to add 1. Multiply 2, add 2. Multiply 4, add 5. Okay, sweet. But we're not done yet because this has nothing to do with this, right? I mean, it does, but it just doesn't look like the same thing. So remember, we're trying to divide. So our answer, if we can think about it, what should the degree of my answer be? What times x minus 2 would give me x to the 4th, blah, blah, blah. If you're thinking a cubic, then you're right. So what I generally have my kids do is I like to draw a box here. This last term is always my remainder, and I'm going to build up constant x, x squared, x cubed. If I had more terms, I'd keep going up and up. So it's like I'm building backwards. So my final answer, these represent my lead coefficients. And then for my remainder, it's going to be my remainder over my divisor, which was x minus 2. And here's my final answer. Wasn't that so much easier than doing the long division? I like to think so. Now, what if I asked you to find f of 2 using the original function? So given that we have f of x equaling x to the 4th minus 3x squared plus 1, why don't you go ahead and find out what f of 2 is? So go ahead and put me on pause. Okay, so if you did this correctly, you would have gotten that f of 2 is 5. Now, where else have we seen 5? Well, if you go back to our synthetic division, remember the remainder was 5. And also, what did we synthetically divide by? 2. Super interesting. That leads us to our remainder theorem. Oops. Okay, so our remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder equals f of k. So for example, we just divided by x minus 2. So f of 2 was equal to the remainder, which was 5. That makes sense. So this time we're given that x plus 3 is a factor of this polynomial function. And we want to find all of the zeros. Okay, so if it's a factor, what does it mean that the function's value is? Something for you to think about. But what I'd like you to do right now is I'd like you to go ahead and do what we did above, and I'd like you to use synthetic division. And just to get you started, what number is going to be in our box here? The opposite of this, which is -3, or you could get that by setting this equal to 0. So go ahead and let's see if you can line up these coefficients and synthetically divide. Okay, so hopefully you were able to get this set up correctly. Remember that we always multiply diagonally and then we add vertically. So when I did this, I got 5, 3, -2, and a remainder of 0. Don't forget we always build up, so this is always my remainder. Oops. Get rid of this. This is my remainder, this is my constant, x squared, and so on. So I get this quadratic, which I can factor, which gives me 3 of my zeros. Now, remember, it told me that x plus 3 is a factor. That's how we knew -3 was a 0. Also, notice what was our remainder when we divided by -3? 0. That also makes sense because if something is a 0, then its y value should be 0. So assuming that we had did, let's say, synthetic division with -1, what do you think the remainder would have been? 0. Okay, so, that gives us our factor theorem. A polynomial f of x has a factor x minus k if and only if f of k equals 0. So again, we know it's a factor if its remainder is 0. And then just something for you to think about is what are 2 other ways you could have potentially found the zeros without division. I'd like you guys to take a moment, think about it, write it down, and then we'll move on. All right, last one. So I'd like you to show that x equals 2 minus root 5 is a solution to this equation and find the remaining solutions. So remember, if it's a solution, then really its remainder should be 0. So we're going to do synthetic division. This one will be a little bit tough, but be just fine. So let's have you go ahead, synthetically divide, and then we'll see how you did. Okay, so synthetic division, we put our lead coefficients down. Hopefully you did that correctly. We didn't need any placeholders here, which is nice. So bring down the 1, multiply diagonally, add vertically. Some of this you might have done the multiplication off to the side, like some scratch work, and that's totally fine. But notice, and it's kind of confirmation for me that I did this right because I did get a remainder of 0. And I said that that's confirmation just because the original problem told us that this 2 minus root 5 was a solution. So it should have a remainder of 0. Now when I build this back up, remainder constant x squared, notice that I get this quadratic. And we were told to find the remaining solutions. So I wanted to factor this, which I was able to do. Now, this is just going to take a little bit of thinking. I see these root 5s in common, so I'm trying to think, how do I multiply to get, this -6 minus 3, but add to get this 1 minus root 5. And, I do get these 2 factors here, which gives me my other 2 solutions. So I have -3, 2 minus root 5, 2 plus root 5. Now it's by no coincidence that these both were solutions. One thing that we do know is that whenever we have radicals, that they come in conjugate pairs. So because 2 minus root 5 was a solution, automatically we had to know that 2 plus root 5 was going to be solution as well. So how else could you have shown that this was a solution besides division? And honestly, maybe it's an easier way than what I just did above. So let's have you guys write that down. All right, so in conclusion, long and synthetic division can be used to find zeros. For long division, we divide by a term with highest degree, multiply, subtract, and repeat. Synthetic, we can only use if it's in the form of x minus k, if the divisor that is. We add vertically and multiply diagonally.